Hello. So we are going to be thinking about polygons here. So multi-sided closed shapes that all have only straight lines. And there's kind of different types of polygons. One specific type of polygon is called a regular polygon. So in a regular polygon, there's sort of a few rules that must be true in order, it must meet all those sort of constraints in order to be a regular polygon and not just any old polygon. So in a regular polygon, you can see that here's an example over here of this 1, 2, 3, 4, 5-sided shape. So this is a regular pentagon. It's regular because in a regular polygon, it is a polygon in which all of the sides, right, are congruent. So that means that every single side is the exact same length. So you can see that they're all marked with this one hash mark. The one hash mark is telling you that it's one hash mark long, whether that be 7 meters or 12 inches or whatever it might be. It also, in a regular polygon, is saying that all of the interior angles are congruent. Interior meaning inside of the polygon. So there are sort of, you can imagine there's interior angles here, but there's exterior angles that go on the outside. We're not concerned with that here. We're just thinking about the interior angles. And in this case, you can see that they all are just, we know that they're equivalent. They could also be marked if you wanted them to be, if there were other types of angles sort of on the angle with a hash mark. Be a legal move, but is a little redundant in this case. So when you have a regular polygon like this regular pentagon right here, something pretty cool is that a line of symmetry divides the polygon into two congruent parts. Every regular polygon this is true for. And it's kind of like, feels like a little bit of a math magic trick here. The number of the number of lines of symmetry inside of your regular pentagon is going to be equal to the number of sides. Oh, I kind of gave it away there before. I spoiled it. So the number of lines of symmetry is equal to the number of sides. So in this regular pentagon, since there are 5 sides, there are going to be 5 lines of symmetry. Pretty cool. So if we think about that, right, we could cut it in half. Like if this was on a piece of paper, we could fold it along a line like this. So we could start at this angle in the middle of this tip at this vertex and kind of go straight down. We could do that same thing from this vertex, a perfectly straight line, and fold it across this line to make a line of symmetry. Same is true, it's not straight, for all of these vertexes if we cut it across. So we have 1, 2, 3, 4, 5 lines of symmetry. Boy, I wish my lines were straight. So down here, you get to try it out, right? So your first step 1 is it a regular polygon? And if it is, then you get to show that many, depending on the amount of sides, that many lines of symmetry. So in example 1 here, we have side, 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 all one hash mark long, implying they're all the same. Angle, 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 all 60 degrees. So we know the angles and the interior angles and the sides are congruent. And so we know that this is regular. So we would say, Yahoo, regular. And then we're going to add in those lines of symmetry. So if we went from this vertex, that's pretty straight, and cut it and cut it. Oh, not quite as straight, and cut it like this, right? You can see that we could fold along those lines and it would perfectly match up. That is what it means to be symmetrical. On this next one, we'll say, ooh, I see a line of symmetry. I know I could chop it from here to here, right? However, before I can do that, I want to recognize that there's 2 steps here, right? Determine if it is a regular polygon. Is it regular? Well, 1, 2, these all have a single hash mark long, right, for their side lengths. However, I see some 90-degree angles and some not 90-degree angles. So this is not a regular polygon. And so that sort of same rule does not apply here about the lines of symmetry matching the amount of sides. So go ahead and try that last